Good morning, everyone. Thank you so much for joining us this Cinco de Mayo. It's so great to have you guys with us for getting started with spatial analytics using Alteryx. I am your host for today. My name is Heather Harris. I am our practice director of data science and analytics here at PK. And what we'll be covering today is oops, just hit that slide too fast. We're going to cover really Alteryx and spatial analytics. What does that even mean? How do you get started with spatial analytics using Alteryx that you already hopefully have? If not, you can go ahead and go to their website and download a trial. Spatial analytics and transportation, we'll go over a use case there and teach you about some of the tools used in Alteryx there. We'll talk about spatial analytics in retail, and we'll also talk about spatial analytics in telecommunications. And I have three of my colleagues with me today who will be sharing about those different areas, and we'll introduce them as this morning's workshop continues on. PK is the experience engineering firm. We bring you solutions to help you in the experiences that matter to your clients, to your customers, to your employees, to your partners. We are a global consulting firm. We have over 4,000 employees worldwide. We're in 4 countries with 22 global offices. We have 5 service lines across all of PK, and we do business in all of the different verticals you see. And today we're going to talk about 3 of those verticals. We're going to talk about transportation and logistics. We're going to talk about retail, and we're going to talk about telecom and media. So this just gives you, speaking of those verticals, this lets you know some of the clients that we've already done work for and brought successful experiences that matter most to these companies. And when you're using a technology like Alteryx, it never sits alone in your company's environment. There are always a lot of complementary technologies, a lot of technologies that you integrate to, and this just shows you some of our partners that tend to be in the analytics and Alteryx environments that we design to or that we provide solutions and services for. We are part of our intelligence and analytics service line here at PK, and we bring great design to strong analytics and strong design services. We end-to-end analytics solutions. So everything from what is the strategy that we need to develop so that we can bring analytics and data science and spatial analytics to our organization. We do end-to-end solutions. So we come in and we partner with you. We are strong believers in working alongside you and teaching you how to fish for yourself so that you can be empowered to do the kind of work that we're helping solution for you. And we help you with organizational capabilities as well. So now we're going to go ahead and dive into Alteryx and spatial analytics. So today we're going to go through a variety of topics all around the tool set that's provided in Alteryx, and these are some of the topics that we will be talking to as we go through today's workshop. In the chat window is the link to the materials for today. We'll provide you with some starter workflows, and we're going to be providing you with data so that if you would like to follow along with us with your own Alteryx designer, you can do that. We'll be talking in that way. This will be very much a hands-on workshop. But I also want to say that even though we've designed this workshop for folks who are already comfortable and familiar with Alteryx Designer, you don't need to have or know Alteryx Designer to get a lot out of this workshop today. You can follow along and watch, and then after the workshop, we'll be providing you, you'll be able to get the data and the workflows, and we'll be providing you with this so that you can follow along at your leisure at home when you want to. And so today, feel free to just watch and listen and learn as we go. So our first presentation, or our first section, if you will be with Trayson Marks, and I will go ahead and turn it over to Trayson without further ado. And Trayson, please be sure to introduce yourself to everyone, and let's dive into transportation.
Hi everybody, my name is Trayson Marks. I have been using Alteryx in one form or fashion over the last 5 years. I am an Alteryx ACE, very involved with the community and doing presentations like this, as well as providing solutions to our partners, generally in the data pipeline, but I have worked with transportation companies, which has brought me into this geospatial space. So that's what we're going to talk about today. And without further ado, we'll just go ahead and jump right in. Today we're going to talk about a few things. We're going to talk about some like base level things around, the geospatial capabilities around Alteryx, and we're going to do that by talking through what a spatial object is, and then talking about shape files, and then beyond that, creating points and polygons, and then diving through a use case. The first thing we need to talk about in Alteryx are spatial objects. Now there are 3 types of spatial objects, and they look different than other data within Alteryx, and we'll show you what that looks like in a second. But there's 3 things you have to understand. There's a point and a dimension, a point, a line, and a polygon. Now a point is a single point in space. There's no dimension to it. There's no length or there's no width to it. It is just one spot. Usually can be broken down into like X and Y coordinates. Then beyond that, there is a line, and a line shows something like a route or a border to something, and that has a single dimension. We've now added dimension, and that's length. So it's a connection of points to create that single dimension line. And then we have polygons, and polygons are connected lines that have like a boundary. So if you wanted to do something like if you look at a map and you see a state, the shape of that state would be considered a polygon, or the shape of a county, or the shape of like a city block, which is what we're going to use today. Those are all polygons. There's a few ways that you'll find spatial objects stored within Alteryx. .shp are generally the most common. Those are shape files, and that goes back all the way through Esri, and that's where that originated. So when you download things from usually government sites have a lot of the geospatial like free data out there. You'll get them in shape files, SHX files, or DBF files. If you are sharing data with geospatial information in it, or spatial objects, you can share it through a YXDB. And then also, if you have a SQL server, there are some ways to store this stuff on different SQL servers, whether it's like Microsoft SQL or database or something like that. If you don't have a spatial object, there's no problem. You can create a point through X and Y coordinates, and then through a series of other processes, which we won't really dive into today, you can create polygons and you can create lines and things like that. So you have to have the X and Y coordinates of that object to start that, which we'll go through that in a second as well. There's 2 tools to do that. We have the poly build, which again requires those points. That's how we're going to, like, if we wanted to build our own polygon, and then trade areas, which are going to create circles, concentric circles even around a single point, and that's what we'll be specifically diving into today in my demo. So without any further ado, here's our use case. In the city of Phoenix, they have a light rail that goes through there. It's about 20 miles long. It goes through some different parts of the city demographically, and so the question kind of around this light rail is, who is this serving, and does it make sense? This has come up actually in the city a few times recently. Does it make sense to expand the light rail, and does it make sense to continue to support the light rail? So we're going to answer a pretty basic question here. Is like, what kind of demographics from like a median household income are being impacted immediately by the Phoenix Light Rail? It has 38 stations across the Phoenix Metro and with a 50,000 people daily ridership. Yeah, so what we're going to do is jump over to Alteryx. Sorry, I have been disabled from sharing my screen.
Try it now.
Thank you. Alrighty, so this is Alteryx Designer, which most of you have seen. Just to go over a few things here, this is the canvas. This is where we drop our tools. This is the configuration panel over here on the left, and this is where we are going to, when we drop the tools in there, we're going to make sure they work via this panel, and then we're going to see our results from our workflow here in the results panel. We have, in the data set that went out, there were two sets of data to look at. The first one is all of the stops along the Phoenix Light Rail, and the second one is the actual route of that light rail, which we'll use to demonstrate lines versus points. So there's a few ways to connect to data. For me, I've already got them saved somewhere. So if you downloaded and extracted those files, you're just going to want to make sure that you jump in and click on either street centerline.shape or light rail stops.yxdb. I'm going to go ahead and connect to light rail stops.yxdb through this method. And then I also want to show you that if you have those files saved in a folder and you know where they are, so like I know where this light rail stops, light rail line shape file is, I can just click and drag and bring this onto my canvas. The connection is already made. So if you don't like, navigating through a bunch of different directory locations to find a file, it is quick and easy to do that. So when we bring in that data, we get a little demonstration of what the data looks like over here. So it brings in the first 100 records, and here I see that we've got some sort of object IDs, an ID around some of these things here, and then we've got a type which looks like just some meta information, and then there's where the location is. And then what's really important is that I've got my X and Y coordinates here in the last two columns. And then in this data set, it looks like I've got another, object ID, and then some information probably important to the city, and then dates, so whenever these lines were created and worked on. And then I see I've got something called spatial object here. And for us, it just shows line or polyline in this preview panel. When we run the workflow, we see that there is a spatial object existing in this record. Now, what's important to note is that even if you're clicking on here, you are not seeing what's in here. You have to have a browse tool in order to actually consume the spatial objects. So you can either, click, go to your go to your in and out tools and drop a browse on the screen, and then it'll automatically connect if it's close enough, or you can hit Control-Shift-B, a real good quick key on that, and it brings the browse tool to you. So after we run that, we take a look over here on the left, and we see, okay, there are some objects here. We've got all these different lines which seem to be different parts of the rail system. I tried to zoom in, but it didn't. And then over here, it looks like we don't have anything really happening because we don't have any sort of geospatial object. It just has some information around, the data within. Which, because we know there's no analytic value to us on that. So we're going to just move this browse over here real quick, and then we're going to start using these awesome spatial tools that Alteryx has provided for us. So as we discussed, earlier, points are sort of the basis of any polygon build. So we want to bring in our shape, And because I've got them named centroid X and centroid Y, it automatically picks that up in the tool. And what we've created now is a centroid, or a point on the map. If I click on these, and then over here, so you'll notice there is now a profile tab and a mapping tab. If I click the map, I can start to see these, these stops. If we remember what the line looks like, it makes sense that they would all sort of travel that same path. And then also something you might notice is like, oh, I just see these points. I don't see anything behind it. What's going on? You are able to, up here at the top, pick a position. Or sorry, a different map type. So you've got, okay, cool, now it overlays this and we see that this is within Phoenix. And then there's also, like, if you are a dark kind of background fan, they've got those available as well. But for this, we're just going to use the light. Cool, so we've got our points. And then if we go back to the, the original question of what we're doing here today, we want to think like, okay, we need to see who's really affected by this. Like what city blocks are within, let's say, walking distance, let's say a mile from these center points, and how do we figure out what that looks like? So Alteryx also has a built-in tool called trade area, which allows you to create these concentric circles or single circles around a point. I'll show you what this looks like real quick before we dive into the configuration. So right now you see that we've got these big massive circles around each one of these points. And there's a lot of them because they're all individual spatial objects. It doesn't, create a 5-mile boundary around all of them. They all get their own 5-mile boundary. In order to adjust that, we can change the value here. And then there are, like, if I want to change kilometers, I could, or drive time in minutes if you have the Tom data available to you. You can also create, again, concentric circles. So if I wanted to say, oh, I want to see all of the everything within 1 mile, and then also everything within 2 miles. Yeah, so if you wanted to, if you want to see that, if you notice, they are actually 2 separate radii. So if I've got around here, I've got the larger one and the smaller one. So they are actually showing up as 2 separate spatial objects, and that offers a larger variety of sort of analytics around that. Rather than having to drop this tool in there a bunch of times, you can do it once, and it creates a new record for every distance. But for this one, we're just going to do one. And from here, what we kind of want to do is decide that we want to bring all this information together. Now, if we go back to the original kind of question, we realize that we want to see the city blocks within like a single circle. Like, I don't necessarily care that a block is affected by 2 of these radii. I just care that some part of a city block exists within all of these circles. So we're going to flatten this into like a single spatial object, because again, I don't care that there's a bunch of circles. I just care that it's within this one larger area. So there are ways to do it with the spatial tools, but luckily our transform tool, which is our transform tools, the summarize tool specifically, works really well with these spatial objects. So if I go down here into the spatial section, I can just click combine. And it's going to go ahead and flatten that whole thing for us. So now I've got one polygon that is the area that is all affected by these stops within Phoenix. One thing I did notice is that I lost all of my my specific stops, and they aren't really important for us like to build anything off of now, but I do want to see them. So I'm going to go ahead and go to spatial. I'm going to combine those as well, so that when we are looking at it, we can see the area affected. Okay, and also there are these are our. Now what I also want to do is bring this light rail information into it, just so I can, get a nice clean map where I see the light rail and the stops in the area affected. So we're going to do a similar thing here because, again, now we've got all these broken down into different parts of the light rail, and we don't necessarily want to have that, this larger set of data going. So we just want to summarize this into a record. And also, you can rename things here. So if I wanted to say this is line, we could, so that, now that we are working with a bunch of spatial objects, it's hard to remember exactly what they are. So this is the trade area. So I could say affected area, and then these are stops, so that we understand what's going on. So now, okay, I've got one line, which we can see here in our data, and then I've got our affected area and our stops. So I've got these three spatial objects that now exist in two different work streams, and we have to bring them in together. There are a lot of ways to do this. You can use a join, and you can join on position, or if you want to use a find and replace, you could do that as well. I'm sorry, not a find and replace, append fields. And that's what we're going to do. Append fields is really nice because it allows you to do some other funky things in Alteryx, like if you wanted to join everything to everything, or if you really just need a single record and you need to put it against every single record that's coming through, append fields does a really good job. And it also works, similar to a join tool, in that you can see everything. You can see the names, you can see the object types, you can adjust those from here. It also allows you to kind of work with how you get errors, because there may be reasons why you don't want to append. But for this, we're going to just go ahead and allow all appends. We're not seeing warnings. We shouldn't get more than one record out here anyway. But if, let's say, we had, this unbroken, like if it was still the 21 records, it would give us an error saying, if we had an error or warn on more than 6 records. So now we've got our cool little map here. We can see the area affected. We can see the light rail going through here, and we can see all of the steps. From here, I'm actually going to jump to a separate workflow because there are some larger things that take a long time to set up, and there's some proprietary data that I can't really share with you as far as like city blocks and mean income. We grabbed this Maricopa County block information, or block groups rather, and what that tells us is we've got the block group ID, and then we've got a median household income in there, and then if it's got a name, we've got one. Some of these block groups don't have place names, and as you see here, we've got a spatial object of some sort. And we'll actually take a look at this just so I give you an idea. Okay, so this is all of Maricopa County, and you've got all these block groups. If you haven't been to Phoenix, this is kind of the metro area right here, and these are largely desert. So desert or mountains. So there aren't a lot of people living in there. So maybe it's not super important for us to know this, but we bring it all in. In order to bring these two data sets together, in order to see where our polygon overlaps with these blocks, we're going to use the spatial match tool. This is, again, so all these are up here in the spatial, and it allows us to compare a target to a universe, and the universe is going to be like what your big area is. So for us, our polygon, we want to see which targets or which city blocks exist within our universe, or exist at some point within our universe. They don't have to wholly exist because we have it set up for intersects, but this can say where the target is within the universe, or where the universe is within the target. All these things, you have options down here. So we're going to run this real quick just so I can kind of show you what's going on. So now we have taken all of this, that larger Maricopa County information, and selected all of our city blocks that are affected. So what's cool about that now is we have median household income for these, and then unfortunately for analysis, we kind of discovered pretty late in the game that it might be important for us to have something like population density in there, which if you have some of the insights add-ons from Alteryx, you can get all that stuff, which is actually where this household income comes from. So what we've done is some further cleaning of the data here. We removed where the median household is 0 because maybe there aren't any people actually in that city block. And then we use the tiling tool to create groups of median household income. So after we do some summary, we have, there's a min and max range of household income, so that when we select them, we can kind of see where where these city blocks are kind of spread out into. So for example, if we want to see, where we have this low medium household income of $7,810 to just under $12,000, we can see, okay, there's a city block here and there's a city block here. So, you might think that they would be close to each other, but these are actually kind of far away in central Phoenix. And then you've got these areas of high income. And so, okay, you've got this one, which isn't too far from those two that, were the lowest income, then you've got 2 up here and 1 over here. So there seems to be some, separation of these income levels within within our data set, which is actually kind of interesting because, part of the argument is that like this is really good for generally lower income folks that live around the area. But according to this data, we do have some folks with higher, levels of income that are directly affected by this by the light rail. So what's tough is that we can now see this, but we're drawing these things from the data we're seeing. So us as analysts, we understand that, okay, this is interesting. We've got some grouping here and some grouping here, but what we want to be able to do is create something that the average user can consume quickly. And we can do that with our reporting tools. And this is where some expertise in what's happening is important, because this probably took 30 minutes to set up because there are a lot of things that you have to be doing here and you have to really understand what's happening. But through this, we've been able to create, a report that shows, green is higher household incomes, and red is our lower household incomes. And we can now quickly see, kind of this area with, these are all the city blocks that are affected by it, by the light rail, and this is just kind of the bigger group that is affected by it. And there's actually, kind of a big mix here of the data, because what we've done is now compared it. So we don't necessarily want to compare only the money that's made within this area. We want to, compare the money that's made within this area to what's not in this area. So there actually seems to be a pretty broad, dispersion of income across this, across this light rail line, where, you've got the Paradise Valley area. If any of you are familiar with Phoenix, this is all, there's a lot of money go kind of up this way. But again, here in Central Phoenix, it seems like that's also something that's happening. And over here in Tempe, that's understood because that's where Arizona State is. And then over here in Mesa, because it's growing out this way, which is interesting kind of thing that's happening as the light rail has expanded this way. Perhaps, income is kind of spreading that way as well too. So because it's, again, really interesting. You see here at the end of these, of this area is where the end of this, higher income level just drops off immediately. So maybe there is some value with pushing folks with, income, or maybe there's something like a correlation, which we don't understand yet because we don't have the data around, maybe businesses are growing up around the light rail because now there are more people have access for there's more worker access because of free public or affordable public transportation. So these are all things that we, with something like geospatial analytics, maybe we didn't discover anything here that we didn't know before. But what we have done is kind of gotten an idea of what things look like, and from this we can drive more questions from our data. And if we don't have that data, we can go find it. So that's kind of the big picture for me right now. This is going to be, kind of scratching the surface, and very excited to go through you guys this journey with our other two presenters. Do we have any questions? I think we're saving questions for the end. So without further ado, I'm just going to go ahead and hand this over to Amanda.
Heather Harris again, and I just want to, before we jump into Amanda, I wanted to share that it looks like we were missing an SHX file for the shape file for that last session. We want to let you know that we will give that to you later so that you can do that one on your own. We do have all of the data is complete for the next two sections that we're getting ready to dive into. So not to worry. We do see that that was an oversight, and we didn't load that into the path you received, so we will get that to you later. And then our next section is with our very own Amanda Smith, and I'll let Amanda go ahead and introduce herself and let you know about her background and her expertise in telecommunications spatial analytics. On to you, Amanda.
Hi there, thanks Heather, and thank you Trayson. So my name is Amanda Smith. I'm a solutions engineer at PK, and in addition to having a analytics consulting background, I also have a background in GIS, and I've worked in telecom doing spatial analytics in my previous life. So I've also used Alteryx since about 2017, so new-ish, but in a lot of the usage that I've done has been around the spatial capabilities. So I'm a big fan of Alteryx and its spatial capabilities. Okay, and I can go to the next slide. All right, so I just want to talk a little bit about spatial analytics and telecom. Alteryx is very useful in solving some of the spatial analytics problems in telecom. Coverage areas, a lot of telecom is centered around geography. You know, so if you're in the case of providing cell tower coverage or any kind of like fiber coverage, you're going to be looking at a map and analyzing geographic areas to figure out, you know, what your coverage expanse is and where you might have gaps in coverage. And you're also going to be looking at things like zoning and different restrictions around specific jurisdictions that you're working in. And then also just like asset management, deployment strategies, and a variety of different uses. And you're going to be answering to, as a spatial analyst in telecom, you might be working with the RF engineering team looking at coverage, and then you might be working with the permitting solutions teams, helping them provide what they need to get the permits for sites in specific jurisdictions. So I'm going to focus on a use case. I feel like Trayson gave us a pretty good introduction, so I'm just going to dive into my use case here. And this is a very generalized site selection use case for telecom. I say generalized because there's a lot that goes into site selection for telecom, and it varies by municipality. And what I mean by that is, you know, if whatever specific city or county or state you're working in, you might be answering to all of them in terms of different permitting requirements. And you're looking at a variety of variables, typically from tower height to, you know, interference from hills or trees, buildings, all sorts of stuff. So to keep this kind of a simplified, very general use case, I've, you know, kind of just dumbed it down to, for the sake of this demonstration. So the use case here is that we have 17 potential small cell sites within a specific city, that's Fort Collins, Colorado. And we need to provide the permitting team with the 5 most preferred sites based on 2 possible variables. And we're going to look at these variables and kind of narrow down which ones are most important once we've seen it all on a map. And so those 2 variables are going to be the overall area of the new coverage proposed and the number of parcels. So, you know, property that is potentially inhabited by people. We want to see how much of that is going to be covered by some of these new sites and make some decisions based on those values. So yeah, we can go to the next slide. So these are just some tools that we typically use in telecom spatial analytics, some of many really. And these are some of the ones that we'll be looking at also in this use case. And you really can solve a lot of problems for a lot of different, verticals in telecom. So without dwelling too much on this, because a lot of these I think were repeated from some of the stuff that Tracy covered, I will dive into my demonstration. Okay. All right. So you should be seeing my Alteryx canvas here. And for this demonstration, if you'd like to follow along, I'm going to have two files here that I'm referencing. So the first one is this made up list of proposed cell sites. And for that, it is just an Excel sheet. So I'm looking at Microsoft Excel SX. I'm going to choose that as my file type. And I'm actually just going to back out of this real quick. So I'm in my telco site selection. You should have a file structure that looks like this if you want to follow along. And I'm referencing this data folder. And the only Excel SX file in there is this Fort Collins _SC sites, which I will open and just choose sheet 1. SC stands for small cell. So in this particular use case, we're going to be dealing with all of the new sites are going to be these small cells, which are essentially much smaller in height. And they're kind of used to fill in the gaps where the large macro cell towers that you might see out in the middle of a cornfield, for example, those are going to have a really large coverage footprint, but they may not reach certain areas, and you can fill in some of those coverage gaps in theory with these small cell sites that are smaller, and they can attach to like a telephone pole and be interspersed within the city limits, whereas you might not be able to put a big macro tower in. So in this list, I'm going to just run it real quick so you can see what's in my list here. So I actually have all of these small cells that were being proposed here. And then I also have the existing macro towers that are in the geographic area that we're going to be analyzing. And what we're going to be looking for is opportunities where there might be coverage gaps. And that's why I wanted to bring in these existing cell towers, these macros, so that we can analyze kind of an estimated coverage area with that data. I'm also going to bring in this parcel data, which is something that I grabbed from the City of Fort Collins GIS website. And something you might find if you're starting to do spatial analysis, there's a ton of free GIS data out there. So if you're working in a specific municipality, you can often just Google their website or find the city or the county's GIS website. So in this case, I just said Fort Collins GIS download in my Google browser. And Fort Collins is a beautiful GIS portal. You can see their maps, you can interact with their maps, and then you can also download a plethora of GIS information. I also want to point out that Tracy mentioned some of the block group and population and income data that was proprietary. That is a data package you can buy from Alteryx, and that's where that proprietary comes from. But you can also get a lot of that information for free from going to the census website. So there's something called Tigerline shapefiles, which is essentially all of the census data that they collect is made available in a geographic format for you to download for free. And so it's an excellent resource if you're doing any kind of demographic analysis or a wide variety of analysis. So those are two excellent sources to start by getting free data. So going back to the parcels, I'm going to also go to the files here. I'm going to look for a shapefile. So I'm going to click on the Esri shapefiles. And in that same folder, the data, you'll see a parcel shapefile. I just want to point out, if you were to open this data folder in your file browser on your machine, you wouldn't see one shapefile. You'd see a combination of files, including the SHX file that we referenced earlier, and DBF file, and a few others. All of those combined make one shapefile. So looking at it, since Alteryx is being told to look for a shapefile, if all of those files aren't included in that same folder, you won't see a shapefile available to you when you're looking. So that might answer some questions for some of you who are looking for that earlier. So I choose this parcel shapefile, and I'm just going to run it here so you can see what's in it. So give the map a second to render. So you can see here that this is polygon data. So looking at the table down here at the bottom, you can see a bunch of polygons, and over here in the map view, you can also see that I have polygons. And so we have a spreadsheet now in these parcel data. So I'm going to start at the top here, getting these small cell sites ready for analysis. So I'm going to start by creating points. So Jason went over that in his. I'm going to connect that here, and it already navigated to my Latin long field because that's how I have them named. And those are the only ones in here that would match. So Alteryx figured that out. Good job, Alteryx. And what I'd like to do next is actually split these out. So if you remember earlier, I showed you that I have small cells and macros in that same list. And so I'd like to filter them by site type. So I'm going to split these out. I'm just going to say small cell here. And then and then what I'd like to do is create buffers for both of those. So I think Trayson showed you guys the trade area capability earlier, and what I'm going to use here for this is buffer. I could also use trade area for this, but I wanted to just show you how, there's a variety of ways to do different things in Alteryx in terms of the spatial tools. So starting with small cells here, it's going to ask you to choose your spatial object. So there's only one spatial object in here, and that's the centroid that I just created with the create points. And I feel like actually I should go browse and run that real quick. I don't want to assume that this is making sense to anybody. Can you hear me? Somehow I feel like I got muted. Okay, so I'm going to set the unit of measure here at miles, which is the default, and then I'm actually going to tell it to read from a field, and I'm going to point it to that radius field. So it's going to set everything, all the buffers here to a half mile. I also want to point out that the buffer tool, the difference between that and the spatial, the trade area tool is that you can choose points, polygons, and lines to create a buffer around, whereas in the trade area tool, you can only work from a point. So for small cells, we're going to do that half a mile radius, but for the macro, I think I'd actually like to override that 2 mile radius here. Let's just say hypothetically I got some new information and I want to be a little more conservative on the existing coverage area. And that could be maybe due to the macro height. Like maybe we were originally accounting for 75-foot towers and now we're looking at 50-foot towers because somebody got the data wrong. So I'll go over here and I'll override that and pull that, create that buffer from a specific value, which I'm going to set at 1. All right, so I'm going to just add some browses here and run that. So we'll see what that looks like. All right, so we have our small cells, which are nicely spread out. And then we have these macros, which are much bigger. All right, so what I'd like to do now is I'm going to have a little bit, these guys right here, just for the sake of room. So one of the things I want to do to the macro coverage is in order to do some processing down the line, I actually know that I need to combine this existing coverage into one spatial object. So one of the tools that you can do spatial processing outside of the actual spatial tools is this summarize tool, which I love. I use it all the time. You can, when you have data that has spatial objects in it, the spatial selection down here becomes available. And what I'm going to do here is combine this. And I'm also going to rename in here so that the output is not confusing for me, and say existing coverage. I'm just going to do abbreviation there. And then in order to rename my new buffer for the small cells, I'm going to just bring in a select and call this, all right, small cell coverage. All right, so now I would like to bring in the existing coverage for every row of the new small cell coverage here. So to do that, I'm going to append the fields using this append tool, and I'm going to turn off this error setting down here that errors on 16 messages or appends or more. And then for the output, I guess we can keep all of them for now, just to see what it looks like. All right, I'll run that. So now I have all of this in one file. And what I'd like to do next, which is the reason we did the append, is this spatial processing. So what I'd like to do here is so I'll go back to this browser real quick. So I have the existing coverage, which are these large green circles, and then I have the newly proposed small cell coverage. What I'd like to do is clip out from these shapes represent the small cell coverage. I want to clip out any areas that are overlapped with the existing coverage, because I don't want to analyze, you know, duplicate coverages. Essentially, I want to find net new coverage that we're proposing, because if it's a site that is already being covered by the macro, we're not interested. This city's not going to buy it. So in this spatial process tool here, I have the option to set my first spatial field and set my second spatial field, and then determine an action here. So what I'm going to do is set my first spatial field to the existing coverage, and then my second to the small cell coverage. And then I'm going to choose this option here, cut first from the second. So you can see that as I move through these, it kind of shows you what it's going to look like. And so that's really helpful if you're not exactly sure how you need to set that up. When I was first learning this tool, I had to mess with this process here, these tools here of appending and just getting my data lined up correctly before I could figure out how to even work this the way that I need it. So that's something that is a little tricky at first, but then once you've done it a few times, you start to think preemptively about how you're going to set your data up in order to use this tool. So don't be overwhelmed if you try to do it on your own and it is a little tricky. So I'm going to cut first from second, and then I'll do a browse after this so we can see what that looks like. All right, so you can see now, and I don't know how well it's going to show up on the screen, but what we have here is, and this is how I know we have the 3 spatial objects here now, aside from looking at the table, is that we have these green circles, we have these red circles, but the part that's outside of the coverage area is actually this purple color, which to me is indicating that there's a 3rd spatial object. So what I'm going to do now is just turn off the ones I don't need so I can actually see that this looks the way that I want it to. So I'm dropping in a select tool, and I'm actually going to turn off existing coverage and turn off that small cell coverage. And now we have a new spatial object process, which is going to be proposed, let's see, coverage area. So this is going to be the net new coverage. Let's make sure that looks right. All right, cool. This is exactly what I wanted. So I have all of these small cells, but only the parts of the small cells that are not overlapping with the existing coverage. So you can see already that there are some that are not going to be good candidates, right? Because there's only a very small amount of net new area. Well, that's one of the attributes that I need to look at actually, is what is that area amount? So the tool that we have here in the spatial tools is this spatial info tool. I love this tool because it does so many cool things. Pretty sure I've said I love every one of these tools so far anyways. It's because I do. So in here, what I want to do is analyze from this proposed coverage area spatial object the area in square miles. So I'm just going to check that box. It's as simple as that. And just run that real quick. And now we'll go down here and look at the table. You see now that I have area in square miles of each of these polygons. See, this one has a 0 because it got totally clipped up. So that's pretty cool. All right, now that I have kind of created this proposed coverage area, I've determined the square mile area of each of these. I now need to go down here and work with this parcel data. I'm actually just going to pull this up just a little here. So as I said earlier, this is polygon data, and actually what I want is to be dealing with the centroids of the parcels. So I'm going to use that spatial info tool again, and I'm going to now choose the option to create a centroid as a spatial object. The centroid, as it relates to a polygon, is going to be the geographic center of that shape. So Alteryx just does the math for you and figures out what the geographic center is. So I'll go ahead and do that, and then let me just do the browse here just to show you what it looks like. All right, now we have a lot of points. You can see in some of the larger parcels that it does appear to be the center of that. So I'm actually going to just select what I want from this now, just for the sake of, if I was using, this is a very shortened list of all the parcels in Fort Collins, and sometimes when you're using very large spatial data sets, you're going to want to like minimize or trim the fat as much as you can, because sometimes they can be pretty cumbersome for your machine, which is another reason why Alteryx is great, because some of the other spatial analytics tools that I've used can be very, very bogged down by spatial data. So what I'm going to do here is turn off this other spatial object, which is a parcel, and keep on my centroid. Okay, so now I want to capture which centroids intersect with my newly created proposed coverage area. So I'm going to go up here to my spatial tools again, and I'm going to bring in a tool called the spatial match, which essentially joins the data spatially. And I think Trayson covered this one as well, so I won't go into too much detail, but I'll show you how I'm going to use it. So my target area is going to be the coverage area. And I don't know if you can see it here, but let me just scroll in. On the spatial match tool, you have a T input and a U input, and then you have an M output, which stands for match, and a U output, which stands for unmatched. And a lot of times you want to look at both of those outputs, just like you would in a regular join tool, just to make sure that outputs are as expected. So I'm going to bring in this parcels centroid data as the universe, and let's just make sure it's pulling in the right spatial data in case I didn't turn something off. It is, and centroid. All right, and I usually just give this a look over too, just to make sure if I need to rename anything, it comes out the way that I want it. All right, and then I'm going to add both browsers to this one here. So I'm going to see what it looks like. All right, so let's look at the matched. All right, cool. So all of those crazy amounts of points, we now see just the centroids, just the points that are intersecting the proposed coverage areas that I have here. And then here, you can see that it's looking at a site, a coverage area that was in that group that actually was chosen in an area where it covers 0 parcels. So that's interesting. This one would probably have, in terms of looking at area square miles, the most amount of area. It actually covers no parcels. So that's something that you maybe would not have assumed initially going into this, but it's a great thing to know going out. You might want to report that back to the permitting team or something to let them know, like, hey, we have this perfectly good site over here, but actually it covers no parcels. So that's why I always like to check both outputs here. Let's move through this. So now I want to kind of, now I have my results. I know what what sites are covering which parcels. I want to analyze that. So I'm just going to bring in the summarize tool here and just group some of these for analysis. So I'm going to take site ID and I'm going to group that. And then I'm also, just in order to bring the square mile value over, since it's unique for each site, I'm going to group that. If you're familiar with the summarize tool, you probably know that you have to do that sometimes if you want to bring the data through. You could also just join it back later, but for the sake of time, I'm going to do it this way. And then I'm going to count centroids here. And that is going to give me a count of the parcels in each of them. So I'm going to change the name of the centroid count so I know that it's the parcel count. All right, and then we can export that or run that and get it. Okay, great. So now I have a list of the sites. I have their area covered in square miles, and then I have a count of the parcels. So one of the things I want to do here is just grab the top 5. So I'm going to go to these preparation tools, and I'm actually going to sort these by parcel count descending. And since I know that area covered doesn't necessarily mean that it's a good candidate, I'm just going to look at the parcel count now. We'll bring that data over, but I think the parcel count is going to be the helpful factor in determining which site's a good candidate or not. So since I sorted those descending, I can now select the top 5 and put a browse after, run that. Now I have a list of the top 5 sites in terms of parcel count. And we can, if you wanted to join that back with the original data so you can look at it on a map, you could do that just by bringing in a regular join tool and then joining them on site ID. I feel like I've probably taken up a lot of time, so I will leave it there. But this is essentially how you could do a very minimal version of site selection for telecom, you know, just to get the ball rolling. And that is the end of my demo.
Thank you so much, Amanda. That was excellent. And it's just really great to see all the different things you can do with the spatial tools. I know that there's a common expression among spatial folks is that everything happens somewhere. And so we saw in Trayson's presentation how you can use spatial analytics in the transportation industry. And actually there's so many other use cases that we've been involved with around trucking, around how airlines move cargo. Sometimes airlines work in partnership with trucking companies to move their big cargo containers. I like to call them igloos, but those big containers, you see them load onto airplanes. And just even different routes around trucking and things like that. And then in telecommunications, Amanda, thanks so much for illuminating just the start of all the different things that you can do. And now we're going to actually pivot and we're going to start moving into retail. So again, just to show you the diversity of things you can tackle. And so for those of you who are following along or who are watching along and you're going to try this out on your own later, this will help you know how working on this skill set and the time you're investing today can really help you in a diverse array of applications. So next up, I would like to introduce you to Rod Light, and Rod is going to dive into spatial analytics in retail. On to you, Rod. Oh, actually, really quick before I do that, I do want to mention If anyone has any questions, please go ahead, feel free to enter those in the Q&A window. In your Zoom, if you look in the controls, you should see a Q&A. You can pop up the Q&A window. You can enter a question there. And then after Rod's session, we're gonna start going through all the different questions that you guys have been submitting throughout today's workshop. And we really enjoy having you with us today. So Rod, on to you.
Thank you, Heather. And my name is Rod Light. As Heather said, I am with PK as a senior solutions engineer. I've worked with Alteryx actually for about 8 years. Actually worked for Alteryx before I came to PK, and have been in the consulting realm for around 20 years, but focusing in Alteryx in the last 8. So what we want to do is just kind of go through what we have in the realm of the retail kind of use cases. And Heather, if you want to move to the next slide. Yeah, so what I wanted to do is just kind of talk through, because there are so many kinds of cases that you can use spatial analytics with in regards to retail. And I've been in the retail space for some time, doing a lot of different things as far as the spatial and all of that. And so I just thought I would list here and kind of briefly talk through kind of where retail can utilize spatial. And as Heather mentioned just a few minutes ago, there is that quote that kind of goes around: every transaction happens somewhere. You know, and in a sense, it's obvious. Well, of course, every transaction happens somewhere, but sometimes it's really not fully understood as to how important that can be, especially in a retail arena, where the transaction occurs really is important. It indicates customer buying preferences, their behavior that can be used for further marketing to customers. I'm currently working with a client that has a seasonal business and has what you might call snowbird customers, and understanding where and when they purchase product in a national chain of stores can assist in more effective marketing, promotions, even stocking of products. So from the idea of product management. So one of the things that you can talk to is basically marketing to customers that are close by. That would be the first thing you would look at. Some of you may use a GPS app on your phone, maybe like Waze or something like that when you're driving around. If you do, you may have noticed and seen pop-up ads that say, hey, there's a business that's right around the corner. Do you want to go there? When a business is brick and mortar, the proximity of the customer's current location is important, as well as knowing where a customer lives, where they work, so their daytime address per se, where they shop, can help with better marketing and should have an effect on how they are marketed too. Then you have, of course, marketing to customers that are far away. And when you start talking about that, it starts a discussion and analysis of multi-channel marketing, whether or not you have online email catalogs. Knowing that a customer may not be conveniently located to your brick and mortar means that you need to market through those other channels. And understanding when the customers aren't that close to your physical stores will define the approach you have with them. Then you can get into actual analysis of the stores themselves. Where are the physical stores located? Should bring in the analysis of demographics around the store. What consumer demographic segments are there? What is close by? Because as we're going to kind of, in our use case, we're going to talk about is naturally, if you're closer to the store, it's going to lead to more visits. And all of this can lead to, of course, segmenting locations, store locations based on those demographics, which can define product placement, pricing, and local advertising. And then you have, in regards to that brick and mortar, you have things like white space analysis and cannibalization. So white space analysis is, where are you missing opportunity? Is there sufficient opportunity in areas where you don't have locations to invest in creating a presence? Is the best investment an actual location, or really are you better off leveraging, those other multi-channel kinds of marketing capabilities and selling product online? On the other side of things, there's the opposite of that, which is where you're over concentrated in your presence. And that would be where you have so many locations that it tends to have a negative effect on the bottom line, because you have too many assets that are too close for not enough customers. And so you tend to then have what can be called cannibalization of your customers across stores. And then, you know, distance, it's an interesting thing to think of distance as a part of customer overall value. You know, as I've kind of talked through these concepts, hopefully you started to think about how distance to customer might actually play in defining what is that overall and lifetime value of the customer. This comes into play especially with loyalty programs. And understanding how far the customer travels to do business might actually have an impact on how you set that overall value for the customer, and the offers that you're actually willing to provide them. You know, and then finally, we've talked about customer analysis and marketing and store analysis, but with retail especially, there's operational, you know, considerations. You know, where you potentially have locations and distance and drive times for you know, your distribution centers, your supply chain analysis, as Trayson talked about, just transportation in general. Those kinds of spatial concepts can affect operational decisions when you're talking about placement and that whole supply chain thing. So from that, let's just go ahead and dive into well, actually, I won't cover this really in detail, because a lot of this, I'm sorry, Heather, I jumped one. If you want to go back, I won't cover this in detail as far as the actual tools, because I think all of these have been kind of looked at, except probably the find nearest. But all of these are tools that are typically used, again, in retail spatial analytics. And we'll cover each of them, although some of them have already been done. So I'll kind of go over some of those more at a higher level. But let's just go ahead and jump into the hands-on. And so let's see here. Okay. And what we have is, of course, Alteryx that we've opened up. What I'd like you to do, and in the data that we provided, and I'll just kind of open up so that you can see where it is. So in the data that you provided, when you unzipped that folder, you should have ended up with two subfolders under a main folder, one where it has the workflows and one where it has the data. And what you can easily do, if you have a Windows open, you can actually come in and you can just click on the Windows, the workflows folder, and you can go in here to retail example start, and you can actually drag it onto the screen. So if you have that available, you can do that. I'm going to actually then go though to the actual open the workflow so that you can see how that works within Alteryx, where I have the same thing here, and I'm just going to click on my retail example. And the reason what I've done is I've set this up because you know, Trayson and Amanda have done a great job of going over the create points, the trade area tool, which are the tools here. So I have it kind of set up with your data already in place. And if you open that up, you should just be able to click the run button and it should just run. And so what we have here are a list of a small set of customers. And actually, I'm going to click on the browse afterwards. So we have about 2,600 customers, and you can see that all of these customers are kind of around the Denver metropolitan area. We have some stores, and I have just a small sample of stores here. And what I've done is I've actually created a 2.5 mile radius around it, each of those stores. So this would be designating the trade area. So if you think about it, the example we're going to be talking about here is in regards to retail, and think maybe convenience store, small grocery store, think 7-Eleven, Dollar General, even Starbucks would be something that might have this kind of analysis. And in a previous analysis, we've determined that customers that tend to visit stores are within 2.5 miles of where they live. So we have this 2.5 mile radius set up around each of the stores, and the kind of analysis we're dealing with, because where these customers are. Typically, you're going to have some sort of loyalty program or some other way to track specific customers where they've signed up in an app or something and registered where they have their address, and so it allows you to do that. What our use case is going to be is I also have 3 potential new stores. So I've just created 3 potential new sites, and it's hard to kind of see where they are because the little points are so small. But there's one up here by Thornton, there's one over here by Aurora, and then there's one down here to the south. And what we're wanting to look at is where to put a potential new store. So this is going to be that white space analysis. And then we're going to follow up with that same customer coverage. So I'll show you how cannibalization might look. And so we're going to look at both of those as kind of a use case for the spatial process and the spatial tools within Alteryx. So what I'm first going to do is I need to be able to look at the coverage that we have within Alteryx, within the 10 store points and what that coverage is. And what we want to do is we want to see, well, what are we already covering in the way of customers here? And to do that, we're going to use a tool that both Trayson and Amanda have kind of gone over again, and it's that spatial match tool. Spatial match tool, again, is sort of like a spatial join, and I'm going to go ahead and bring in from the customer side, they're going to be my target, and I'm going to bring in from the store side, they are the universe. And Amanda mentioned this as well, that there is a target and a universe, and basically this matched and unmatched is whatever you want to see as matched and unmatched needs to come through as your target. And you need to set it up so that it's set the correct way. And what I'm going to do, and I already have the I've set it up so we already have renamed, this is the customer location, this is the store location and the store trade area. So what I'm going to do is it kind of defaults to the customer location, which is my target. That's what I'm wanting to analyze coverage on. And then in the universe, and this is something that I always used to miss when I was new with Alteryx, was it defaults to that first centroid, and of course you can't match a point to a point. As Trayson mentioned, there's really no dimensions to it all except that lat long, and so you always want to make sure that you come down and you actually get the polygon that you're looking for. And so I'm doing that, and then what it allows me to do in here, and it's very flexible and a robust tool in regards to spatial matching. What I want to do is and if you just kind of think, here's my target, which is customer location, and I have my universe, which is the store trade area. So what I want to match up to is where the target is actually within the universe. So if you think about it, where the customer falls within that circle or that radius. So I'm going to click on that, and I'm going to add browses to both sides so that we can see what we have here. I'm going to click the run button. And what it's going to do is it's going to, on the match side, what's going to come out of the match side is all of those customers that fall within those 2.5 mile radii. Sort of like what Amanda did as far as the census blocks that fell within those cell phone towers. So concepts are the same, but the use case is a little different here. These would be identified then as my customers that are probably most likely going to stick around because they're within 2.5 miles of a store. Now, what's interesting though, and Amanda kind of inferred that sometimes it's really useful to look at the unmatched side, and on the retail kind of use case, it really is, because what we can see now are all the customers, and you can see the blank spaces here where the store trade areas have kind of taken it in on the other one here. You can see if you kind of go back and forth, you can match between these are the areas where it has captured those, the trade areas have. And so then these are kind of the white spaces where customers were captured, but more importantly to what we're interested in is we're interested in what customers haven't been captured. So these are the customers that are not so close and actually may be subject to leaving. You know, instead of going to 7-Eleven, they may go to the local Circle K, that kind of thing. And so what we want to do is we want to determine from our 3 potential new stores down here, what might be the best location to capture those customers that are still kind of at risk, if you want to call it that. And so we're going to bring in a new tool that hasn't been discussed today, and that's a find nearest. And so I'm going to bring in the find nearest. And again, it's fairly easy to set up. It's got the target and the universe and the matched and the unmatched. But what we're wanting to do now is from our unmatched, so in other words, the customers that are highest risk here, I'm going to bring the unmatched and hook that into my target. And then what I'm going to do is going to bring in from my potential stores into that universe. Because what I want to do is I want to say, so out of these 3 locations, I want to find for each of these potential unmatched and at-risk customers, I want to find what's the closest of those 3 potential sites that there are. So if you look at what the configuration is for the potential sites or for the nearest find nearest tool, it's going to be that customer location. And I'm going to look at then what is the nearest to the new potential site. Now, I only want the nearest point. I could say, give me a list of 1, 2, 3, or however many I want here. But I'm really just looking to match 1. And I really am only interested in getting that distance of 2.5. Now I can go to 2 here and say 2.5 and type in what I want here. And then what I'm going to do is, let's go ahead and just drop in again some browses so that we can kind of see the effects of it and what we have here. And what it's going to do is it's going to say, well, out of this 986 customers, out of those 3 locations, we found 137 where they're within that, they're as close as 2.5 miles. Now we have, again, so this is answering the question of which customers that aren't already in a good trade area are closest to that potential new location. What this is telling me down here in the unmatched is these are customers that aren't covered by even the new locations. So these might still be even at risk after we've picked a potential. But what I now want to do is I want to say, okay, well, I have my 3 locations. Which potential store covers the most existing customers that in a sense, if we built a new store, would already kind of have a market that already exists? Well, to do that, and everyone has been using the summarize tool because it is a great tool to use for this kind of analysis. What I want to do is I want to turn around and say, for the label, which is the name of that potential site location, I want to group on that. And then all I want to do is I want to take the customer and count. So just a very simple, it's not going to be a complex analysis, but I just want to go ahead and say, you know, what is my coverage here? And so if I look at what comes out, I can actually see down here that of my 3 sites, if and again, there's complexity all over the place as far as where I would put a potential location, including the demographics of the location and does it fit and all those kinds of things. But in reality, for this simple kind of basis, I can see that news site number 1 would actually give me the most coverage of those at-risk customers. So that's kind of a very simple look at how you would use spatial tools and spatial analysis to be able to kind of look at a white space for where your locations is if you're from a retail brick and mortar. And so now we're going to shift gears and go the opposite way. And we're going to say, well, out of all of these customers up here, if we think about all of these customers, where am I over, well, and even more so on these stores, where am I overlapping coverage? Where do I have kind of that risk of cannibalization? And again, it would be more with the idea of probably putting in a new location, but we're going to use the existing locations just to see if we have extra coverage on that type of thing. And so to do that, what I need to do is I want to get the store data to be able to compare side by side every store location trade area to every other store location trade area. I want to match them up and say, is there an overlap? So the first thing I'm going to use is that handy tool that, again, the other Trace and Amanda have both kind of talk through here, is I'm going to basically say, let's just bring in from the same source, I want to put them side by side. And this is a little different than what they've been doing as far as the use of this tool. But again, it shows how robust Alteryx can be when you're trying to work with these things. And as you can see here, I have the target and the store, and basically everything is the same. What I'm going to do is, just to clean it up a little bit, I'm going to uncheck all of the variables because I really don't want to look at all of this over again in my analysis. I'm going to just take the store ID from the target side. I'm going to take the store location and the store trade area, and then I'm going to take the store ID from the source side, as well as, again, the trade area and the store location from the source side. So if we look at this data, I'll just run this process. If we look at the data, what we're going to end up seeing is, we're going to end up seeing, here is the information from the target side of store 100. Here is the information for the source side, and as you can see, I've matched up 100 to all of the other stores here, including itself. So basically the tool is just doing a cross join to be able to match everything up. So out of my 10 stores, I'm actually getting 100 records. Well, the first thing I want to do is, I really don't care when the store is matching to itself. I know there's 100% overlap there. So I'm going to go ahead and just start kind of cleaning up the data from that perspective. And basically I'm going to say, let's just eliminate, and let's see here if it'll pop up here. Yeah, so let's go here and let's just say where I don't want where the store ID is equal to, so I'm going to say not equal to the store ID from the source side. So the first thing I want to do is eliminate those 10 instances where the store, and you can see down here on the faults, I have my 10 instances where the store is equal to that. Now that I have my comparison in place, the other 90 records where I'm comparing the actual spatial objects of the target to the source, excuse me, what I want to do is bring in the tool that Amanda kind of showed off a little bit, was the spatial process tool. Now, she used it in a different way, and again, from the standpoint of how robust Alteryx has made these spatial object tools and the processes that you can have. I'm going to show you a different look of how we're doing it. First thing I want to do, though, is I want to make sure that I am looking at the actual fields that I want. So I want the store trade area, and I want to compare that and do a process against the matching the source store trade area. And the one I'm going to pick on this is, I want to see where there's actually an intersection. And as Amanda showed here, you can see that what I'm going to get out of this process is what is in this bright green number 3. I'm going to get the overlap, which is what is important to me, because I want to see where I could potentially cannibalize customers. I'm going to click the run button just so that it kind of runs through and shows you what the results are. So I still have my data, the original data, but over here is the spatial process intersection. Now you'll see that there's a lot of nulls here, and if you think back to what does my data look like? If I compared this store trade area to this store trade area, there is no overlap. So the process would come back and give me a null value. And that's what we're seeing here, is that over here, I have a number where they did not have any kind of overlap. So since I only want the intersecting points, I'm going to bring in another filter tool just to eliminate that. And that's going to be real easy, where I'm just going to come up here and say, you know, that spatial object process, I want it where it's not null. If it's not null, that's what I want to see. So here we're going to turn around and then see that out of that, I have 14 different records left where I actually have a spatial object process that is sitting there. Now, one thing you're going to notice is I'm matching store 100 to 105. And if I come down to here to 105, you can see I'm also matching to store 100 because it was a true cross join. So the first thing I'm going to do is I'm going to, and it may be not that intuitive, but what I'm going to do is I'm going to find out how big those intersections are. What is it that we're talking about here as far as size goes? And there's other, of course, perspectives and parameters that would come into play in dealing with this kind of an analysis. But this is, again, meant to be just to show you how easy it is to get to that point within Alteryx. And what I want to do is I want to say, how big a square area is that in square miles? We'll do miles instead of kilometers here. What I want to do is I want to understand just how big of area that is. So again, and this is kind of how, when you're building out a workflow, you do it, you add a new tool, you click the run button, and what I'm going to see over here now is I'm going to see and I'm going to go back and say, and again, this is something you gotta make sure that you get the right spatial object that you're analyzing, because what I did was I said how big of a square mileage is a point. And as Tracing kind of pointed out at the very beginning, there is no area to a point. What I wanted to do was really find out on that spatial object process, the intersecting point. I wanted to see how big that was. And so again, that's how you kind of work through with Alteryx, is you say, gee, I didn't get what I expected. Now I am getting some square mileage. And what I want to do is I want to, because I have that situation where I have the 100 and the 105 matched here, and the 105 and the 100 matched here, you'll see that those areas are exactly the same naturally. So what I'm going to do is a new tool that we haven't really looked at that can be useful for something like this. I'm going to say, well, I want to get the first one of those grouped on the square mileage. So I'm grouping on square mileage, and I only want the first one of those. And again, it's kind of a basic for the demo. You're assuming here that to a 3 decimal point, the intersections aren't equal of 2 separate different intersections, but that's going to get me what I need as far as now getting me back to the 7 combinations where it actually has the intersections. And now I want to see which of these has the biggest intersection. So I'm going to just bring in a sort tool, and I'm going to sort it on the basis of that in descending order, so that I can turn around, descending order. So I can turn around, run it one more time, and I can see which of the areas has the highest overlap. And if we look here at that, we can see which area has the highest overlap. I'm going to go ahead and bring in a browse tool so we can actually visualize this and see it on a map, where we look at that. And if we look at where that is, it is these 2 stores right here, store locations, is what has the biggest chance for cannibalization or over concentration as far as coverage of customers. So that's kind of a walkthrough again from a retail standpoint. I wanted to point out a few other things about Alteryx that you can get. We've done it on the basis of no one in our audience having the spatial packages. But I kind of wanted to talk through what those spatial packages kind of can do for you, and especially in the retail world. If we go back here to the trade area tool, Trayson talked through how to set it up, but one thing he didn't mention, because it wasn't as applicable there, but it really is applicable from a retail standpoint, is the whole idea of drive time. A radius as the bird flies can be useful, but in reality, when we're talking about brick and mortar and we're talking about where people live, we're talking more about how long does it actually take for them to get to the store than it does how far it is as the bird flies between their house and the store. And Alteryx provides as third-party data in their spatial insights package. They provide TomTom as a drive time methodology. And as you can see, you have a variety of different choices that you can make. You can say, am I marketing people at off-peak times, at pure night times, or at peak times? And I just kind of wanted to show you what that looks like and why that would make a difference. So now that we have drive time in minutes, the value up above is actually referencing minutes. So I'm not concerned now about how far it is. I'm wanting to look at, okay, well, if it takes 15 minutes for me to pull out of my garage and get to the store, that's probably the biggest that you would expect someone to drive to one of these, 7-Elevens or Starbucks or Dollar General, that kind of thing. And so I've changed the parameters here. And again, you people in the audience don't have that data to do it. So you can just kind of watch now at this point. But I'm going to go ahead and click the run button so that we can see what this actually looks like. So what it's going to do is it's going to, for every point, it's going to go through the process of going down every road, freeways, that kind of thing. And of course, freeways, you can travel faster than you can on side streets or back roads. And what you can now see is what happens if I pick, and let's pick one that's easy down here, and I'll just kind of zoom in. What you can see is here is the store location. And if we think about how far does it take to get somewhere in 15 minutes, you can see that I can head up this freeway quite a ways in 15 minutes. But when it comes to maybe over here where there's not that many streets, you don't get as far. The other thing about the drive time trade areas is, as you can see here, for instance, and I'm going to move over to this one because I think it actually shows up better, is for instance, here we have a park. And so if you think about it, we have the store that's located here. And if you went with just a straight as the bird flies kind of process, that radius would incorporate all of this. But as we all know, we get in the car, we may have a lake that is there or a river, and we have to go down a ways to get across on a bridge to get back. And so something that may be just a quarter of a mile away across a river could actually be a 20-minute drive during peak hours. And so again, this is where drive time comes really into a valuable concept when you're dealing with retail types of marketing and understanding where people live compared to the store, because it's not that radius that really matters. It truly is how long does it take for that customer to get there. So that's a concept that I just wanted to make sure I shared. And then I wanted to just kind of go over to other kind of what I would call functionality possibilities. And what I've done, and again, this is something where you don't have the data. I'm utilizing the third-party data that Alteryx provides in the Business Insights package, but I'm taking that same 10 stores. And as I mentioned when I first started, you start getting into store locations and you want to understand what's the market that is around that store? What are the demographics? What are the consumer segments? And I just wanted to kind of give you some ideas on other things that Alteryx can do. And again, if these are things that in your company, it's going like, gee, we've never done this before. How do we approach it? Of course, we at PK are experts at this, and we're very much happy to be able to help you with the ability to start down the road of the spatial analytics and demographic analytics and that kind of thing. But just as an example, I've again taken that 15-minute drive time, so we can look at those things, and you can see I have the drive time now. But what I want to do is I may want to look at a specific store. So a store manager, say for store 100, would like to understand what kind of people live around my store. And this is just a standard report. Alteryx, in Alteryx, you can do your own customized reports. But as you can see in this report, standardized report, just a wealth of information regarding the 2010 census. I have some old data, but it would be current data. 5-year projections out, what has changed. So in other words, you're understanding what are growing areas, what kind of income there are, how many people live there, all of those kinds of demographics that might matter to a business when it comes to reporting and deciding where they should actually have a location, number one, and number two, how they should actually market to that location. Because as you can see from demographics, it really would matter as far as what you have here. So wanted to show you that. Also, the idea is so this is a standard report for that store, but you can also, again, Alteryx is really robust where you can take this customized trade area and you can basically pick your own variables. So I've just picked a few here, but as you can see, there's just a wealth of different things that you can actually pick. You know, statistics around what the average expenditures are in various different verticals and industries, daytime population if you're trying to get to businesses, you know, consumers when they're working. They have their own mosaic segmentation through Experian. They have the segmentation of already done as far as what those consumers do. So you can basically then come in and say, okay, for these stores, here are the different populations. I've just picked a couple of different variables here. And then last but not least, the one last thing I wanted to cover was sometimes you don't have that loyalty list of stores. You don't have specific customers, but you still want to be able to look at, you know, what are the demographics for people in certain block groups. And I have here a note if anyone is interested. We've already talked about it, but I have a note of where you can go to find out really what exactly are those census blocks and what do they mean. But Alteryx allows you to dive in at that very finite block group level and understand what type of demographics there are within that. And so if we look at it, again, here are those very small, and Amanda had already shown them from the standpoint of telecommunications, but the very small areas where you can say, I want to understand who lives in that specific area because I may be interested in putting in a location somewhere that's close to there. And so you could go in and pick several of these and then have the types of things that are the demographics, you know, how many households are there, those kinds of things are available. So again, this is just kind of the art of the possible, what is available to be able to do. And like I said, if you start thinking about expanding your spatial analytics, your things like customer segmentation, store segmentation, those kinds of things, here at PK, we have experts that can deal with that and help you along that journey to get you to where you have a more efficient marketing program or better product selection, all of those kinds of things in the retail world. So with that, Heather, I think I've talked enough and I will turn it back over to you.
Oh, Rod, thank you so much. That was such a great, insightful session and just really appreciate it. And now everyone, we're it's time to start our Q&A part of the morning, and or wherever you are, you might be dialing in from around the globe in the evening. So whatever part of the day you're in at this time. So we have some questions that have come in. I am going to invite our session leaders to each join us so that as questions come in, Amanda and Trayson and Rod can help us field those questions as well. So one of the first questions that came in is there a software that can convert US addresses to lat and long columns? Trayson, do you want to take that one for us?
Yeah. Yes, so Alteryx actually has some built-in tools. I'm going to share my screen real quick again, just so I can, show you what's going on here. There are some address tools that, again, come with some of the insights packages, and it will allow you to break down information about your address based on the based on that address. And so they all exist here. And so CAS is the United States Postal Service data set that you can use to tie into that information. And then you can use a street geocoder. Mine are, of course, based for the US, but they do have data sets around most of the rest of the world. So you're not limited necessarily to a US analysis. I think Canada is really pretty out of the box.
And Trayson, you're a little bit light if you want to get closer to your mic.
I apologize. Yeah, so real quick, high-level answer. Yes, it exists in Alteryx. You've got the address tools here, which are part of the Spatial Insights package. CAS is the USPS data set, and so you can you do a few things here. So you can, with this, you can clean addresses, you can get them ready for spatial processing, and then from that you can break down X and Y coordinates, which then you can create points with through these tools. But they're part of a separate package from Alteryx.
Great, thanks so much. Really appreciate it. Along those lines, let me hop back in for you guys. Let's see what the next question is. So somebody was like, you know, I heard about this business insights. Like, how do we get in on this business insights analysis?
Rod, do you want to talk? I think you.
Rod, you want to take that one?
Sure. Happy to. Yeah. So as I mentioned, the business insights and the spatial insights are both packages that can be added into the Alteryx platform. And so you would want to, of course, contact. You can reach out to Katie or Heather, and either one of them can direct you to the right person that would be at Alteryx that could get you that information. They do have the pricing information for it on their website at alteryx.com. You'd be able to see what that is. But basically, it provides, as I mentioned, the spatial insights provides TomTom primarily as far as drive time, and it then gives you, and you may have noticed that my maps were a little bit different. I'm using the TomTom Max that actually have the streets and everything that are more clearly defined. So that's from and then the spatial also provides the address conversion that Trayson just talked about. That's part of the spatial insights as well, as far as, and also the address standardization through CAS. And then the business insights incorporates Experian data. So you saw that data that I kind of showed in the demo. It's the Experian, and you can there's a variety of different variables. There's something like, I don't know, 40-some thousand variables that they provide that you can utilize, and it shows previous census, current estimates, and then 5-year estimates. And it has a slew of demographics, the Experian, their Mosaic, Simmons, buying survey, retail demand, all of those kinds of things are incorporated into that. And so that would be available, as well as Dun & Bradstreet for a B2B kind of perspective. If you need that, it also has the Dun & Bradstreet as well.
Great, thanks so much, Rod. I really appreciate it. And here's another one for Amanda. So, Amanda, what sort of, well, actually, they premise it by saying, hey, we know about Alteryx being able to do analytic apps. So, can you tell us more if there are analytic apps and what sort of analytic apps have been created specifically for telecom?
Hey, sure. Yeah, there's actually, I mean, an infinite, a, a number of ways that you could support telecom practices with analytic apps. That was one of my favorite things to do with it, was create analytic apps, because kind of took that request process out of the workflow and just put the power in the different teams within the company's hands to just generate the results that they needed. So some of the apps that we created for telecom were, propagation maps to support the engineering teams, the RF engineering teams, who are the ones that kind of design this network infrastructure. And, they needed to, whether like maybe the jurisdiction's asking for an actual representation of the coverage. So what I showed you was a very generalized version of a coverage area based on a lot of assumptions. But the RF engineering team, they're going to create these propagation files, which I would always get them in tab files, tab file format. And we'd convert those over and created some analytic apps so that the engineering team could just drop in their list of coordinates, click run, and then they'd have a nice polished deck that included the propagation outputs on a really nice map background in a PowerPoint format. Another thing, since we're talking about geocoding addresses, that was something that the permitting teams are going to need a lot. They're going in and say they have this point and they want to find the nearest address to it, or or they have a list of addresses and they want to find our nearest site to it, whatever the scenario might be. The permitting team could just go into the analytic app, which is hosted on the Alteryx server, and it was managed by the GIS team. And they could just run that tool themselves and get that list of addresses or get that list of nearest sites. And they didn't have to wait for a turnaround for the GIS team to respond. And then also different things like zoning. Say they needed a map of zoning, or they needed, drive time for the deployment team who are going out to install these towers, or anything you could probably think of, you could turn it into an analytic app. And of course, that just maximizes the efficiency of the overall operation, because it frees up the analyst's time to do other work, deeper analytics, by allowing all of the other stakeholders in the company to just generate their own results. And I just want to mention too, on the geocoding thing, the regex parser tool is an excellent tool to utilize if you're doing address geocoding, because a lot of times you are getting addresses that may not have consistent formatting, and that just, if you encounter that, just remember that regex tool is your friend.
Excellent.
Yeah.
No, okay, do you have some? Yeah, keep going, Amanda. Sorry, I didn't mean to interrupt.
I mean, I could talk all day about it, so I'll stop.
Well, speaking of talking all day, that led to a follow-up question. They're like, what if we haven't done spatial analytics or analytic apps? Like, do you guys have any way to help us get going? And the answer is resoundingly yes. So we have a full team of Alteryx experts. We do formal training, so we can do a formal training, more in-depth than this one, like more of a full day session around spatial analytics, help you get going with your use cases. We also do end-to-end solutions, and what they specifically ask is like, can you come and partner with us and like get us going and help us learn? And so yes, we definitely do that. We come in with you, we help you design your first round of things, but we help you learn how to do it while we're doing it alongside you. And then that way you can go off and do these powerful things yourself. So really, really good questions. There was another question for Rod, actually. Thank you so much, Amanda. Really appreciate it. Rod, when you were presenting, they were asking, is there a limit to distance calculations in Alteryx?
Good question. And the answer is no. However, keep in mind that when you're doing drive time, specifically, what the engine behind it is doing is it's mapping out every kind of likely path between 2 points. And so as you saw, you may have noticed when I went from 2.5-mile radius to 15-minute drive time, it took just a little bit longer because it was actually going through all of those different side streets and everything else to determine how far it can actually go. So naturally, if you're saying, and I've done this, where I've done a drive time between 2 points that was 1,000 miles away. So if you're doing, cross-country transportation analysis, where, for instance, I've worked with tax teams where they wanted to understand the actual amount of road, not just straight line, but the actual amount of road that went across states for tax purposes, to understand what allocation to each state should a transportation path be allotted to. So you can go that far, but just keep in mind that those kinds of things will take a little longer to run, depending on the specifications of your engine. But theoretically, there is no limit as to how far you can go.
Oh, excellent. Thanks so much, Rod. And I think that is the last question I have. And so what I want to let everyone know is if you have more questions that come up, you can see Katie Dixon and my email addresses here on your screen. Feel free to shoot us an email later. We will be sending a follow-up email to each and every one of you that had registered. We'll include today's recording, and we'll also include that updated data set, a link to it so you can get that final file that we needed for that first session. And then that way you can play along at home at your leisure. I know someone did post in the questions that they were at work and they were hoping to be able to do this later on, that they could listen right now, but would participate afterwards as well. So as far as if you need any more information, please email Katie, please email myself, and we can point you in the right direction. There's lots of websites out there. Alteryx community has some good resources. We have, as you just see a few people on this call, but we have a full team of experts in Alteryx data science, and we would love to hear from you. So with that, I am going to officially and formally wrap up our Getting Started with Spatial Analytics Using Alteryx workshop. Thank you so much to each and every one of you who have joined us today. I want to thank our presenters, Trayson Marks, Rod Light, and Amanda Smith. Thank you all so much also for taking the time and to share your expertise with us. For all of you listening, have a great day, and we wish you good health and wellness. Thank you.